Alright, we have on the bench a Philco Model 70. This is a pretty well known model amongst collectors, and I had a customer of mine bring this down in person. Didn't want to take the risk of shipping it. He said he just wanted me to check it out, so let's see what's going on with it. Well, this is supposed to work, so let's see what we got here. Plug that into the wall there. And it seems dead to me. I'm not getting anything out of it. This dial slipping a little bit too. Should be getting some right there. I've got an antenna hooked to it. Or I thought I did. Alright. Antenna connected. Still not getting anything. Should be getting something around 12 to 14. There's something sounds faint. Might help if I turn the volume up a little bit.
Sorry about that. But they started to get something was awry late last night around 10:30, 11 o'clock, and it just did not get better from there. It was so funny. But here, Sean Sebastian clip. They're calling the counting precinct to report votes. This is what happened. This is clip 12.
I'm just waiting on hold and to report the results from my precinct. What are you hearing? I know you're listening to from the Iowa Democratic Party.
Yeah, it doesn't sound all that great to me. It's working, but it don't sound right.
Got off hold. So I've got to get off the phone to report.
Doesn't sound very clear.
Can we listen in as you report it, Sean?
Yeah, something, it doesn't sound very clear. It works, but not very well. I can't pick up anything but the local. Something going on with that volume pot too. So let's go ahead and I'm gonna get this thing out of the cabinet and see what's going on with it. He wanted me to check everything over and make sure everything was done correctly. And I also have the faint smell. There's a faint slight burning smell. So I'm gonna go ahead and pull the plug on this thing so nothing happens to it. And let's get it checked out. Now, before somebody gets on to me about not using a variac or something like that, this radio has already been plugged in and supposedly restored. So it's not like it's an original one that hadn't been touched, and you know, supposedly all the capacitors and stuff have been replaced on this thing, and the guy that brought it to me had already plugged it in and played it before he brought it to me. So just go ahead and eliminate those comments. Okay, so I got the chassis out and been taking a look underneath here. I just turned it back over so you guys could have a look at one of these. This is a pretty pristine looking chassis. This radio is in excellent shape. Supposedly it came from a collector, and he was selling off his radios. So got our tubes in there and 3 more here. So it looks like a 7 tube set. We got rectifier over there. So anyway, so I've never worked on a 70 before, so this is a first for me. I like to look before I do anything. I like to look. So let's see what all we're getting into. So I'm a little bit confused as to what they have going on for caps here. I don't think these are original. They don't look like it. I believe this is definitely a replacement, but this solar here, this one's disconnected, this one's still hooked up. And they've got another 22 microfarad cap done a little strangely underneath. So let's take a look here. Okay, I had to flip it up there. It's kind of hard to do it with the camera, but this is what we got going on here. We've got this 22 microfarad cap here, and we've got like this setup here, and then this piece of heat shrink that's basically split, and they've just got it kind of stuck on there. So we're gonna have to clean that up. I'm not even gonna put that back on there. And then we've got this going on here with the negative. And then we've got a wire here. I don't know why they left this in the circuit. And it's not in the circuit here, and it's not in the circuit here. So this is must be a 2-section, because we've got a single section here, which, you know, this is that Sprague here, and then we've got this going on here, and then it's just grounded to the chassis, so that's a single section. I'm not sure how good this is, and I'm not sure what went on here, if this has been restuffed or what, but I don't see anything obviously, you know, without taking anything apart, that looks like anything's been cut open or, you know, anything like that. So I'm gonna want to test this here. I'm gonna have to pull this out of the circuit and do a test on this and see. But I say we should probably go back with something like that. There's a lot of hum in this radio, and that's probably why, but I don't really know. I'm trying to figure out why it's got so much hum in it. And a lot of this stuff is original, which people like to do, and I have no problem with that, but I don't really know how in spec this stuff is. It's, you know, 80 plus years old, so I don't really know. But anyway, a good look at what's going on here, and the burning smell, I think, is the transformer heating up because of the line voltage. My line voltage here is about 122 volts in this building here, and you know, when these things were built new, the line voltage was 110 to 115 volts. Yeah, see, it's 115 is stock voltage, so I guess 120 would be good, but mine's over 120, so I may not to run this thing on a variac and knock the voltage down to 115 and see how that goes, because we definitely don't want a chance messing up that transformer. Good luck finding another one. Alright, so let me see what they got going on here. I need to go get a schematic for this and see exactly what's supposed to be going on here. Anytime there's stuff that's replaced, I don't like going off of the values that were replaced. I want to go off the values that are in the schematic That way we stay within close range of parts we need for this. I decided before I went in and got the schematic, I would take a look at some of these Bakelites and see if they had been redone or not, and it appears that they haven't. It's still got the gooey wax on the back side of it, factory filled. So if this were my set, I'd redo these like I always do, Bakelite blocks, and go in here and get out that goo and put in some new caps in here with spec to the schematic. And what I meant by these capacitors here, the filters, a lot of times people replace filters that have a close value to the original, maybe a little bit higher than the original value, and there's nothing really wrong with that, going up a little bit. But say I see this is just say this was a 16, the original was an 8, they might have gotten by with that, that's fine. But well, what if I decided to increase that a little more? And you can see where we're getting way off in the original value. So anytime you're redoing some of these radios, my advice would be to look at your schematic, get your original microfarad value and your voltage value. Never go below the microfarad value or the voltage value. This is a 450 volt cap. I would imagine stock is 400, so that's perfectly fine. I doubt this thing was a 22. That seems a little high to me. I don't know what they got going on here. We're gonna look at the schematic and compare that to what they got going on here and see if this needs to be changed or what's going on here. Alright, so going through some of this circuitry. I don't remember where we left off last, but we've got this resistor here. According to the schematic, it is a 50K resistor. Going by the color, it looks more like a 51 to me. I ran into this several times with the schematic. This is supposed to be a 50K resistor. That, according to that color code, that looks like a 51 to me, body and dot. So this is the same way, but I'm getting more like almost 70 out of this one here. This one's like 52, so it's not an issue. But yeah, let me see if I can kind of get you around to the meter here. If you can see that meter there. It's about, if you see that meter over there, it's 69 or so. So this one's going to need to be replaced. I've already lifted the leg on it off of these caps, and it doesn't really make a lot of difference. You probably get like 68 instead of 69. It's not that much difference. So yeah, this one's going to need to be replaced. I believe that's going to be outside of the 20% tolerance. That's about almost 20K higher than what we need. So we're going to have to replace that one. I'm going to see what I can do about getting a dog bone to replace this. I got to do what I can do. We might be able to find like a reproduction dog bone or something like that, but he says if you got to replace it with a modern, just go ahead and do it. So I'm just doing what the customer wants to do. So anyway, the rest of these dog bones don't look too bad. Alright, so I'm trying to figure out the filter setup on this thing, and I don't really know what they got going on here, because this is going in, and there's nothing hooked here. This is supposed to be the positive. At least according to the schematic, this is supposed to be the positive and this is a negative, but there's nothing hooked to the positive. So I'm not sure what they got going on here. And then they got this 22 I have a feeling they have both of these connected to the same capacitor. I'm not sure that's kosher, you know what I mean? I don't know, I'm gonna have to figure this out because I don't know exactly what this is. And this is still hooked in line with that. This, I think, was probably hooked here at one time. This wire here coming in from the side was hooked here. So that would be the negative. And these would be the positives, but this is a dual section cap. I don't think that's original either because it's just a single section cap that was supposed to be there. Yeah, it's got one positive and one negative, and this is the negative and this is the positive. I guess that's why that's disconnected, because they were just using one section of it. But yeah, I don't think this I don't like this. Yeah, so basically I think they've got this all jacked up. They thought they could put one capacitor to serve as two, because on the schematic you have this is 43, this is 41, 43 and 41. One side hooks to this big resistor, multi-section resistor here, which is this. So you've got a line going from over here, right here, and that goes to there. From here, you see it's hooked to here. But then on the other side, you've got, from the audio output transformer, you've got a line where you've got this side of the capacitor hooked to this line. So what they've done, one capacitor is supposed to hook up on this line, the other capacitor is supposed to hook up on this line, and because see, that's shown here, one side of the transformer is hooked to this capacitor, the other side is hooked to this capacitor. And what they did was they wired them together. You got that and this goes to this black wire, which goes to the transformer. This tan wire goes to here, which goes to you can't do that. And then they knock this out of the circuit. This is not even hooked up, and this goes back to the output tube, audio output tube number 43 right here. That's the base. So this isn't even connected, so this is not getting anything out of that capacitor. This is just disconnected. This is just, it doesn't even look like anything was ever even hooked to this. So this is just here for appearances, which is fine, but I mean, hook a capacitor in line. Yeah, they put 122 to serve as both of these, and you can't do that. It's got to have two separate caps, because this is two separate circuits. You can't just wire them together. That's why it's humming. And that may be the reason why I'm smelling something in here burning, because you can't do that. Yeah, more no-nos. And by the way, obviously, I think we've gotten into this thing, and I said that this is another one of those recap jobs, and this is all I could find that they've ever done to this thing. Everything else is original, so, you know, as usual, we're gonna have to redo everything. And so I've gone through the schematic and denoted all the values of these block capacitors, and we've got to restuff all these. And so anyway, I said that early in the video, but this is not correct. You can't do that. Okay, I think I've figured this out by looking at the schematic and kind of looking at the way wires are going here. So this is what I've got temporarily clipped in for a filter system to see if this is going to be right. Let me see if I can show this on the schematic here. Of course, it's going to be the paper that's going to be on the bottom of the stack. So so let me see if I can show this here. All right, 43 is the 43 is the top one. So 43 would be up here, and so 43 is here. You've got one connection to your transformer, output transformer, the other one connected to your 80, the other one connected to the resistor and your transformer. So what I did was, but if you notice, both of these are hooked to the same, both of these filter caps are hooked to the same ground essentially. So, and then that goes back to the resistor there. But so what I did was, this goes back to the resistor here, this wire with the heat shrink on it. So I've got that connected to ground of this cap and ground of this other cap here. And so then I've got this cap hooked to the tan side of this audio transformer, and then this cap with this red wire is hooked to the black side of the transformer, and then that goes back to the tube, which is what is on here, because you have a connection to the transformer here, and then it says C, and then C starts here, and that goes back to the output tube here, to the grid of that tube. So that's where we're connected, and I got that hooked up. And then the other two go to this cap here. These are two separate circuits. They had them combined to one capacitor, and you can't do that. And that's why the radio has such a hum. Now I'm using the same 22 microfarad cap that they had in there for one side of this, which is too high, but this will work for this testing. So let's hook this up and see if this works. I'm going to plug this speaker back in from the cabinet here, and I'm going to go ahead and turn it on. Let me plug it in here. Alright, I plugged it into the wall. Let's turn this thing on and see if it's going to work or blow up. We got our antenna wire hooked up. Hear a slight hum, but nothing like it was.
We put all that together to have one.
Well, that sounds a hell of a lot better.
And we do blade, firearms, stick training, boxing. That's all. Right. And then we mix in some of the Israeli arts, which is the crowd. And we do a lot of situ.
That station's right up the road. I had the volume down so low because the other station's blasting me out so bad.
I mean, but that's why I do, hundreds of sit-ups and push-ups every day.
But that's at no volume. There's no hum at all. So yeah, you can't do that. All right. Well, at least we got this figured out. So now I can order the appropriate caps and get this thing hooked up correctly.
Check it out. Even white boys got the shout. Baby got back.
Nothing like some baby got back on a 90-year-old radio. Alright, so it's been, I don't know, a week and a half, 2 weeks since we're on this Philco last, and we had the filter capacitors here, kind of, well, like this, just kind of rigged up, and we have all of our correct parts now, so got them all ordered, and we just need to put them in. Alright, so I'm going to have to attach this terminal strip to that metal chassis so we have a place to mount our capacitors, filter capacitors. But in order to get anything soldered to this, we need this big mama soldering iron right here. This is my big 200 watt chassis connection soldering iron. I got it on eBay. I'm not sure when it was made. It's probably sometime in the 40s or 50s. But that's a big freaking soldering iron. That's my hand. So yeah, that's it won't even fit in a regular, you know, like a universal stand. Only the tip will go in there. Okay, so we got our terminal strip here, and doesn't look like there's a lot of solder on there, but it's more than good enough. That's not gonna move. So our chassis, our connection is not going to the chassis, so we won't use this pin because it goes to the chassis. But I needed 3, you know, one for the each hot lead of the electrolytic, and then one for the negative. So we're gonna wire that up here. All right, so this is what our finished filter network looks like. These are our grounds, and each of our positives here had to route some wires, use some reproduction wires for these connections because the existing ones were not long enough. So, and the old filter cap they had in here, they had both of these circuits wired on to the positive, and then they had the negative only hooked to this wire here. Just got the heat shrink on, which I left that and just pulled it back over the break in the wire and reshrunk it. They did not have this resistor hooked up here, which went to this cap here and was isolated, so that goes into the ground circuit. So yeah, that's how they had that done. But we split them back over to 2 different separate caps, which is the way they should be. This one's a 10 microfarad, this one's an 8. That's what I replaced it with. The originals were a 6 and 10, so that's what we went with, an 8 and a 10. Alright, I must have something right, because you can go to minimal volume, no hum.
This is the proposal, so we'll see if there's any wiggle room.
That's the volume all the way down.
That next, but if you want to get in, line up.
So took care of that filter hum. Radio still works. So now we'll move on to some other stuff. We have this resistor here that's 51K. It's about 70, so we're going to replace that. And I got to go back through and rebuild a lot of these Bakelite blocks. Alright, so what we're going to do is we're going to start out with this AC line bypass capacitor, which just, you know, basically takes some noise off of the out of the line here, keeps it out of the radio. We got 2 capacitors, got one here, and then shunted to ground, basically to filter out any noise that'll be coming in through the line. So what we're going to do is we're going to use some safety capacitors. Got a whole bunch of them right here, and what we're going to do is just take this screw out here. There's a bite washer that goes to the chassis. If you do any of these, you're going to want to take this screw out, and there's a screw on the bottom side of this that will fall out when you take the screw out. I don't never usually, if I can get these out without disconnecting these wires, I usually do it. They actually make some tools for this. See if I can show them to you here. Got one with like a little drill bit on them here. I just got these not too long ago, just to make it a little easier. And what you do is you run your little pick down in there. You heat this up with a heating gun. You just push that tar out of the bottom of it, and it's gonna this here is gonna work like a reamer here and ream out your holes there. And you know, you just heat them up and you push that blob out the bottom of them, and you flip them over upside down and you run your capacitors from the bottom. I don't do it from the top. You can do it from the top, but for authenticity, I'd rather put these through the bottom and then just solder them in, and you'll never know they're there. They look like the original. That's the way I like to do them for customers, and I explain to the customer before I do them, that's the way it's going to be done, and find out if that's what they want, and it's usually the way they want to do it. So let's go ahead and get this out, and get this out, get this off, get this gutted out, and go ahead and put some new safety caps. The reason why I use safety caps is because if the capacitor was short, it could take out the power transformer. It could cause a problem with the primary of the power transformer. If a cap was to short the ground, it could take that out. So now that we have safety caps, it's better to use those and than running the risk if there was one was to ever short, take out your power transformer, which you're basically not going to be able to replace anymore if it ever goes out in one of these old sets. Alright, so we got our screw out. We got a little washer that came out from this side of, it's going to be on that side there, on the chassis side there. Bites into it to make sure you get a good connection to the chassis for ground. This is what I'm talking about, the little blob there. I've done these on prior videos and show you how I restuff them, but we'll kind of show you how I do it here. Basically, I just take a heat gun and heat this up and go all the way around. You can pry them out from the bottom with a screwdriver, but you're going to not want to pry around the edges here. If you pry around the edge here, you're likely to break this block here, prying against it. If you pry on this side of it here, if you can help it. Other than that, I just kind of pick it out, or if you got a pick like just a regular old pick that'll fit down in here, you can heat it up and push on it, push it out through these holes here. That's usually the easiest way to do it. But I got this special tool here they make for these, you know, this kind of supposed to ream the hole out here. I usually don't have too much of a problem with that unless you heat up the solder, and sometimes you can take solder sucker and get it out, or get you some braid and get it out and get these holes clear. But basically I push this blob out and then put my capacitors in place of that blob there up under the bottom, and then put them back in like that. Alright, that's how it works. You just heat it up from all four sides, and I take that little punch, stick it through one of those holes. Usually use the center one so you can get a good push on it, and it pushes the whole thing out in one big blob. Alright, so now that we got our holes, our block clear from the bottom, what I usually do is just take these capacitors. Alright, and it's complete. We got our two caps in there, and we got them soldered in up the top. We got a little extra lead like that, you can always snip it off, but that's pretty much it. Alright, and that's it back in. And don't forget your bite washer on the bottom. Insert your screw and put your bite washer on, slide it on there, screw it down, good to go. Now we're gonna have to do this about 10 more times and we'll have it done. Gotta go through the radio, and now some of these wire are a little bit different, so you need to refer to your schematic as to how these all hook up inside here, and they have different values. They also have a number on the side too, if you can see that. 4989E on the side here. You can go to philcoradio.com, and they got a list of all the numbers and what their value is, and and all that. So, and tell you how many is in there, and what terminals, how they wire, and all that. So, free tip for the day. Alright, so I want to point out something on one of these blocks here. I've run into this a few times, and but it's not too common from the ones I've worked on. This is actually a combination of a resistor and a capacitor in this one here. It's not just a double capacitor. Let's see if I can show you. This is number 31 on the parts list here. So number 31 is a 250 ohm resistor and a condenser or a capacitor, which is 0.9. They don't make 0.9s anymore, so I'm going to use a 0.1. So anyway, this resistor here is 250 ohms, so that is illustrated here. So you've got this capacitor shunted to ground, which is a bypass capacitor, and then you have this resistor in line. And so this capacitor comes in from the grid of this tube here, number 30, or off the 47 there, comes down. If I can get my bearing, hang on. Sorry, number 24, number 24 tube, not this one. Anyway, it comes off right at 30 here, it comes down and ties into here. So your capacitor is going to be shunted to ground, your resistor is going to go from here to here, and your capacitor is going to go from here to here. So the number on this is 4989. E is an echo. So just thought I'd point that out. I can also illustrate that here. This is not just a it's not just a guess. Let's see. There's your 250 ohm resistor there. So it's reading right on, but because I've got to push this whole block out, I'm going to end up having to replace everything in there anyway. It's reading right on with it in the circuit. Normally something like that, I really wouldn't take it out of the circuit. Now it's kind of fluctuating depending on how I hold the leads. See, it's going down now, but it's pretty close. Normally I wouldn't replace that, but since there's a cap in here that's 90 years old, I'm gonna go ahead and replace it. Alright, so here is the capacitor section of this, and here is the resistor. Basically just a bunch of wound up wire in there. Alright, so here's the finished product here up under the bottom there. And so all we need to do is just cut these off and solder those up and put this back in, make sure the bite washer's on, and we're done. Well, that circuit checks good.
So obvious that I can't believe that.
Alright, so I got the radio recapped. We got all these done. All the Bakelite blocks are done. So I'm not going to worry about these. These are micas, and I've checked them and they're in spec. However, this resistor here is out of tolerance, so we're going to replace that one. Got a reproduction dog bone resistor that we're going to put in there. It's a 51K resistor. So we're going to replace that. Thing's reading about 70K, so we're going to go ahead and replace that one. And this is what I'm talking about right here. Alright, so another capacitor we have are these metal box capacitor deals here. They have a single wire that comes out of them there. And then basically the capacitor grounds right here. I've got one tacked in over here, but and I got this disconnected here from the circuit, but the ground here. Now I'm not going to be able to fit this capacitor in this box, but on this one here, this is a 0.5. So what I'm going to do with this, I've taken the innard out of it. They basically just slide in there. It's like a little shielded type box there, and then this lead here is the ground section of it. I'm going to take a modern capacitor and put it in here. I've got one over here. If I can find it. Anyway, I've got one tacked in here basically to take the place of it here. There's only 9 volts on this circuit, 9 volts DC. So I'm not really going to worry about putting a real high voltage capacitor in here. This one here is a 0.47 at 250 volts. That'll do just fine. So what we're going to do is we're going to put this in this box here, and I'm going to put this cover over it with the wire coming out of it. I'm going to cut this wire off, and we're going to replace this capacitor and put it in that box and put it back in here and run the wire back in there just like it was originally, and it'll have a newer modern capacitor that'll do the same thing, but it'll have the original look. Alright, and that ought to do it right there. Just a big old empty box, but it'll work the same. Alright, so I don't know, it's about a week or so later. I've taken forever to make this video because I had a lot going on. I had a friend pass away, and it's just been really rough lately. So anyway, we got this resistor replaced, and I don't see anything else that, everything else looks fine. It checks out okay. This volume pot, which is more like a rheostat on this one, seems a little flaky sometimes. It's kind of doing it now. I've cleaned it. I've cleaned it. It seems to work most of the time, but it's just every once in a while it's kind of flaky. So I don't know if he wants to replace that or what. I guess I'll have to find out. But anyway, see it kind of popping. So I don't know. Just sit there and it's fine, and then all of a sudden it just kind of does this number. So anyway, I'm going to move on to checking the tubes. We're going to have to replace these insulator washer deals here because he wants those replaced. So you can do that, and the crackling goes away. So it's not only in the volume up, it's in the volume down. You can hear it, and you can kind of just pop it like that all the all the way clockwise, and it'll quit messing up. So I think it's in this rheostat. So anyway, I'm gonna go ahead and see what's all involved. And I think I'm gonna go ahead and see what's all involved with these insulator washer deals here. And the ones he got are a little big, so we may have to cut these down. See if we can get those to work. There it goes again. See, even with it all the way down, it kind of does that. All right, so let's see what we can do with this without making it look too ugly. Okay, so these washers that he has goes here, not here. Those are a different type. Those actually go through the chassis and then, you know, flare out on the other side. They're actually bigger on the other side than they are on this side. So we're going to leave those alone, and we'll just put these here. Alright, so we're going to start out with the RF tube. We're going to check it. Had to use the old precision tester that I've got because of the ICO doesn't, it's got a 24, but it's a 24A, and when you check them, it checks them all week. So I don't think that A worked for the 24. So on this one, this checks okay. It's about 68 or so on here. So that's good on emissions at least. And no shorts. Alright, and this one is our first detector, and it is okay. It's, I wouldn't say borderline, but it's in the good, the lower good. This one is a RCA Cunningham Radiotron. It's one of those ones that's got the etched base to it. Let's see what it reads. About 60. A little over 60. That's probably pretty good for this tube tester. It keeps going up too, so I think that's good. Alright, so this is a Philco. And these are all 24s, by the way. I'm just going and basically I'm just checking all the 24s. There's 4 of them in this set. So anyway, this one's used as a second detector, and it checks pretty good. It's about 65. The last one that I checked, I hit the button again before I took it out, and it was about the same. So the Cunningham and this Philco here check about the same. So for this tester, that's pretty good. Alright, so back on the ICO. This is a 27. This is our oscillator tube, if I can say it correctly. And this one checks 660 out of 1,000. So that's not too bad. Seems to be okay. It's definitely not the 106% that it had written on it, but nevertheless, this will work. Alright, so this is a number 47. This is our audio output tube, and by the way, these are 2¼ volt tubes. This tester only has either 2 volts or 2.5, and it says you should put them on 2.5 to check them, so that's what we're doing. And this one reads about 660 or so. That's okay. It was slow to come up to that, but it's doing okay. I don't see any reason why to replace that. It sounds fine on the in the radio, so good to go. Alright, so this is our number 80. This is a 5 volt filament, or actually 4.7 is what the schematic says, but it says to check it on 5 volts. So we're getting about 700 out of this one, so yeah, no problems here either. And this one here is an old RCA Radiotron as well. Number 80. I like when they etch the number of the tube in the base like that, because so many times when they turn it on the glass it gets erased over time. Alright, we're all put back in the case. Local blasting station.
Now, when you said this a couple of days ago, Dawn in Brazil dismissed these as Russian talking points, but it's actually been very weird. The party's
control works
conduct of
good.
this election, going back to the night before
To turn the volume back up because the rest are not local stations, they're further away. Those 3 are local.
Regarding finances, I was stressed regarding a job that I never got a break from. Okay, you know.
970, our local AM rock simulcast. We'll keep that moving because that's copyrighted.
And we can talk about whether or not Brady is a great fit for Shanahan's offensive style.
Increase your take of salt. You can retain more.
In the 3rd chapter, or the 4th chapter of James, James is just continuing his train.
It is not at night, it's during the daytime, so we're not going to pick up very many stations right now until after dark on this thing. This is a gorgeous radio. I love to have one of these for myself. This one actually works pretty good, unlike my other one.
and the 2 of them going at it for 2 hours. How do you think that's going to...
I'm looking forward to that if that ends up being the case.
My other one's a TRF set. This is actually a super heterodyne. This is far superior. Just can't think of the model number. I've got a video on it.
James gives us 3 enemies.
Okay, so on this, as far as the alignment goes, it basically tells you in the schematic all in certain words not to mess with it, the alignment on it. These receivers are accurately adjusted at the factory prior to their shipment. Under no circumstances are the adjusting condensers to be changed in the field. This alignment requires special oscillator equipment, which all Philco distributors have. In other words, don't adjust them. So what I did, whether I can adjust them or whether I can is not really the issue. It's how to, and I'm sure they have a particular procedure to do that. So what I did was I adjusted it for the middle of the band, which is this station here. It's about the closest thing I could find to the middle of the band. And I peaked it for the middle of the band so it will perform on the lower and the top end of the band. If I peak it for 970 or anything any higher, it's going to do better on the top of the band and poorly on the bottom, so I just did it in the middle and it seems to work. So anyway, I'm gonna call this one a wrap. This looks like another success. Appreciate y'all watching, and sorry it took so long to make this video, and it's been a while since I posted a video, but I've got 3 other sets from this customer to work on, so 3 more. So stay tuned. They're pretty good sets. They're pretty nice old 30s sets, and so I'm gonna try to get on those, but appreciate y'all watching. If you like it, give it a thumbs up. Thanks.